Now, the next topic, which is atomic structure and bonding. Under this atomic structure and bonding, we have the concept of atoms, molecules, and ions. We also have the works of Dalton, Millikan, Rutherford, Moseley, Thomson, Bohr, simple hydrogen spectrum, ionization of gases, illustrating the electrons as fundamental particle of matter. Then the atomic structure, we have electron configuration, atomic number, mass number, isotopes. Specific examples should be drawn from elements of atomic number 1 to 20, shapes of S and P orbitals. Atoms. Atom is the smallest particle of an element which can take part in a chemical reaction, while molecule is the smallest particle of a substance which can exist alone and still retain the chemical property of the substance, or the chemical properties of the substance. While ions, on the other hand, ions is an atom or group of atoms which possesses an electric charge. Then there are some scientists that made a milestone in the contribution to the theory of an atom. We have Dalton. Dalton works on atomic theory, which we stated in the previous lesson. Also, Millikan. Millikan is another renowned scientist that work on the measure the charge on the electron. So in the UTME up to date, they can still ask that you should mention the scientists, or you should mention the scientists that work on the measure of the charge on an electron. So it is then mainly Millikan. Then Rutherford proposed nuclear theory of an atom. Also, he brought about the idea of a planetary electron. Then we talk about Moseley. Moseley assigned an atomic number to an element. Another renowned scientist that also talked about discovery of cathode rays is J.J. Thomson. J.J. Thomson discovery of cathode rays as they glow and moves in straight lines. Also, charge per mass. Then he still proposed another one. Proposed that the atom is a sphere of positively charged matter from which electrons are embedded, and that explains why you have in an atom. Here we have protons and neutrons, while here we have electrons. Electrons revolve around the orbit. So in the nucleus we have protons and neutrons. So then let's talk about our Bohr. We have Bohr, near Bohr, and wave mechanics model. Wave mechanics model, Bohr model. In the case of Bohr model, Bohr talks about a simple molecule such as the hydrogen molecule. But the molecule that is more complex than hydrogen, Bohr failed. So that is why it has limitation when you are talking about more complex atoms or molecules. It only works specifically on hydrogen spectrum, because in his model it restricts electron to a certain energy level, which brought about the limitation. But in the case of wave mechanics model work on the limitation of the Bohr model. Instead of restricting the electrons to a certain energy level, just like in the case of model, it identifies a region which is called an orbital, where there is a possibility of finding an electron with a certain minimum amount of energy that is called orbital. So in summary, in Bohr model, you can use Bohr model to determine the group and periods to which an element belongs or belong. While in the Bohr wave mechanism model, you can use it to determine the block to which an element belongs. So wave mechanism model work on more complicated molecules, while Bohr model only talks about the hydrogen spectrum, the hydrogen molecule. Any other molecule that is more complex than hydrogen, Bohr model definitely failed. So in that regard, we shall be talking about the quantum numbers, and we have 4 quantum numbers which we are going to be discussing subsequently. Now, under the 4 quantum numbers that we have, the first one that we have is the principal quantum number, n. It determines the energy levels, or what? Shells. So what it means is that it measures the distance between the positively charged nucleus and the outermost electron. That is the distance between the positively charged nucleus and the outermost electron. And the second one is the maximum number of electrons that a shell can occupy. That can occupy a shell is 2n squared. Take note of that. So the maximum number of electrons that can be occupied in a shell is 2n squared, where n is the number of what? Electron. So in that situation, that means when you have your K, L, M, or the shell, you have K, L, M, N. So for this one, your n is 1. For this one, your n is 2. For this one, your n is 3. For this one, your n is 4. So if you want to calculate the number of electrons that will be in n shell, then it will just be 2n squared, which will now be 2 into what? 4 squared. And that will be 2 times 16, that is 32. So that the electron, the maximum number of electrons that this n shell can accommodate is 32. Now, the subsidiary or the azimuthal quantum number, it shows the number of energy sublevels in each electron shell. So the number of, if you are picking one electron shell like this, how many energy sublevels do we have? So that is what the subsidiary or the azimuthal quantum number is talking about. Then the third one is the magnetic quantum number. This one, it indicates the number of orbitals in each energy subshell. It indicates the number of orbitals in each energy subshell. Then the last one, which is the what? The spin quantum number, S. The magnetic is denoted by M. This one is denoted by L. So in the spin quantum number, it indicates the clockwise and the anti-clockwise spin of the electron. So it has values of plus half, minus half, just like as it is justified in a shell of, let's say, S, where one electron will spin up and the other one will spin down. That is, no 2 electrons are what? Are identical. They can never be the same. If this one is spinning up, the other one has to spin down. That's why you have plus half, minus half. So let's talk about some other concepts as far as atomic structure is concerned. We are talking about electron configuration. So if you are given, let's say, an element X 919. So the atomic number is 9 and the mass number is this. And the question asks us to represent this, which write the electron configuration of this. We can write the electron configuration in Bohr model and wave mechanism model. So we should know that wave mechanics model or wave mechanical model. So if this and Bohr model is talking about what shell arrangement. So automatically, if I want to write this, it just be 2, 7, where KL. So the K will be element 2, L will be 2, then this one will be, so this is the electron configuration in Bohr model 2-7. But in wave mechanics model, we adopt that orbital model. That's 1s, 2s, 2p, 3s, 3p, 3d. So this one is enough. Strike it like this. Then we have 1s, 2, 2s follow, 2s, 2. The maximum number of electrons for s orbital is 2. The maximum number of electrons for p orbital is 6. The maximum number of electrons for d orbital is 10, while the maximum number of electrons for f orbital is 14. So take note of these points. Then we have 1s2, 2s2, 2p, remaining what 5 to make it 9. So we have 2 plus 2 plus 5, that's 9. So this is the wave mechanics model, and this is the what? Bohr model. So if I'm to write electron configuration of this element, whether it will be 2,7 or 1s2, 2s2, 2p, 5. That is the way to write the electron configuration. And that is what electron configuration is definitely talking about. Then atomic number. What is atomic number? Atomic number is the number of protons in the nucleus